Bismillahirrahmanirrahim. Welcome to my channel, Learn Math with Syed Ali. So we are in the phase of COVID-19, the coronavirus, and we are helping to reduce the spread of COVID-19. Schools are remain closed, and we are isolating at homes to avoid spreading illness to others. And I have started this channel to provide some educational material for the kids. And we are continuing our topic of parabola, and here is the question, which is proof with T.O.V. T.O.V is short form for table of values, and graph that y is equals to 2x square is narrower and graph of y is equals to half x square is wider as compared to the graph of y is equals to x square. So this is the question, and we have to make the table of values for these three equations, which are parabola equation, which are quadratic equation. So we have to start with y is equals to x square, and then we have to prove that y is equals to 2x square is narrower and y is equals to half x square is wider as compared to y is equals to x square. And we know that we are talking about vertical stretch, right? And we learned something. We will conclude it at the end of this solution. So starting with y is equals to x square, and we make a table of values, right? So we make a table of values here for x and y. We give certain value to x and calculate for y, right? So let me make a bigger one so that numbers should not be mixing with each other. So let me make a wider, right? So like this. So x and y, right? So if I give a value of x as 0, what I will get for y? I will get 0. So y is equals to x square. We are substituting for x and getting value for y, right? So now we make 1, 2, and 3. So 3 numbers. We make 1, 2, and 3. So if we give 1 to x, then x square, 1 is square, it remains 1. When we give x 2, so 2 is square, it makes it 4. When we give 3, so 3 square is 9. So I have these values on the positive side, and then I have to have 3 values on the negative side, negative 1, negative 2, and negative 3. And now I calculate here by substituting. So minus 1 whole square brings us back 1. Minus 2 whole square brings us back 4, because it will be positive because of a square. And minus 3 will bring us 9, right? So we have the table of values for y is equals to x square. This is my first table, T.O.V, table of values for y is equals to x square. Then we make the second table of value, which is y is equals to half x square. Oh, first is 2x square. So 2x square, and we make T.O.V again, T.O.V table of values, and we make it here again the same way, same procedure. We make here x and y columns. You can make columns or you can make horizontal, it's the same thing. So this is 0, 0, and then we have to have 3 values, x for 1, x for 2, and x for 3, and then we calculate y. And then we put minus 1, minus 2, and minus 3, and we calculate y. Now, when we calculate y, if we put 1, 1 whole square is 1 times 2 is 2, and 2, when we put here 2, 2 whole square is 4, 4 times 2 is 8, and then 3, 3 whole square is 9, right? 3 whole square, 3 3 is 9, 9 times 2 is 18, so you got 18. And then when you put negative values, it will repeat these values because a square makes it positive again. So you have 2, and then you have 8, and you have 18. So you have another table for y is equals to 2x square. Now you have to make y is equals to half x square T.O.V. So T.O.V is short form for table of values. And then you draw it. So you give the value of x and get the value of y. 1, 2, 3, 4. 4 is 0, 0. And 1, 2, 3. So when you give one value here, so 1 whole square is 1 divided by 2, you get half, right? Or 0.5. And then when you give 2, so 2 to the 4, 4 divided by 2, 4 divided by 2 is 2, so you got 2. And when you would give 3, so x is equals to 3, 3 is a 9, 9 divided by 2 is 4.5, right? So 4.5, you get 4.5, right? Or 4.5. Then you give the negative values, -1, -2, and -3, and you calculate the same thing but same sign, because the square makes it positive. So when you have -half, you have half, and then 2, and then 4.5. So now you have all three table of values. Now what you have to do, you have to prove that this graph y is equals to 2x square is narrower, right? So we will, on the same grid, we will be making a graph for all three table of values or three equations, right? So maybe I have to make some space because I have 9 and this also. So I will draw it again a little bit bigger so that I can plot. So this y-axis no problem, but this y-axis, because I have bigger number, right? So I make it like this. So this is my x-axis and this is my y-axis. What I have to plot is first y is equals to x square. So this is my 0, 0. So for simplicity, I will make bigger 1 and 2 so that we have clear concept of why it is narrow. So 0, 0, 1, 1, then I have 1, 1. So 1 and 1, right? And then I have 2 and 4. So 2 and 4. 1, 2, 3, 4. Right? So this is my point. This is my point. And then 3 and 9. So I have 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you will be making it on the grid paper, it is easier to make, but I am drawing it like rough, right? So just to indicate you, just to tell you that when it is drawn for 2x square, it will be narrow. And when it is drawn for half x square, it will be wider. So we will see how. First, we are drawing this y is equals to x square, the basic graph, and then -1, so -1 and 1, right? So my first point is here. Then I have -2, so -2 is here, and then I go up nearly here, right? So how do I go? I go here, right? Equidistance. And then when I go -3, so 1, 2, and 3, I go here. Equidistance from here, right? So I have my all points for y is equals to x square, and this curve or this parabola is representing y is equals to x square. And I can put arrow because it is never ending. It will go in this direction. Y is equals to x square. This is my first curve. What I have to prove? The values are also showing me that what will be happen if I draw y is equals to 2x square. I will draw it in green so that we can see where the graph is moving to. So maybe we can draw it in red. Yeah, we can draw it in red. So 0, 0, 0, 0 is here again. Now for value of 1, I have value y value of 2. So here it was 1 and 1. Now I have to go 2. So 1 and 2. So my first point is inside the first curve. You can see. So it is getting narrower because for my y values, for the same x value, my y values are bigger. When my y values are bigger at the same point, so my graph or my parabola will be narrower. So when it's 1, it's -1, it's 2. So 2 is here inside that first curve. And when I draw 2 and 8. When it's 2, my y value is 8. So I have to go inside here somewhere. So 1, 2, 3, 4, 5, 6, 7, 8. So I am here, right? You are seeing that my points are coming inside the first curve. So that means if I join these red points, I will get a parabola which is narrower as compared to the y is equals to x square, because for same value of x, we get a bigger number, right? We get almost twice here, right? It's 2 here. Instead of 1, I have to go 2. Instead of 4, I have to go 8. Instead of 9, I have to go 9 times 2 is 18, right? 2 times. So I am going 2 times. When I am going 2 times, my graph becomes narrower, right? Now we will plot the third TOVs, like table of values, which is half x square, and we see with the green marker. So 0, 0 was 0, 0. So my first coordinate is same. And then 1, for the value of 1, I have half. So I don't have to go up to y is equals to x square. I am outside, I am away, right? And then when I plot 2, so 2 is 2, 1 and 2. So I am outside this black line, you can see. And when I am at 3, here I have to go 4.5. So 1, 2, 3, 4, 5. So 4.5 is somewhere here, right? So I am outside the y is equals to x square graph, right? You can see, you can imagine that how and why I am getting this graph, right? So when I draw the minus side, minus 1 and half is here, right? So my first point is here. And then minus 2 is 2, minus 2 is 2, 1, 2. My second point is here. And my third point will be minus 3 and 4.5. So minus 3 and 4.5, which will be somewhere here, right? So this is how my other side of the parabola looks like, joining these values, and this is going in this direction. So the green one is the graph for y is equals to half x square, whereas the red one is the graph for y is equals to 2x square. So I will put red, y is equals to, so this graph is y is equals to 2x square, right? Y is equals to 2x square. So we have all three graphs and all three TOVs, and we have proved here by the graph and by the table of values that y is equals to 2x square is narrower as compared to y is equals to x square, and y is equals to half x square is wider as compared to y is equals to x square, right? So this is what the same thing which we did in our lecture in the last class, that stretch, vertical stretch. So our equation for the parabola vertex form was y is equals to a times x minus h whole square. Maybe I can remove it so that I clear. X minus h whole square plus k. This is my vertex form, right? And this a, we know that this value of a, the value of a is greater than 1. It's a vertical stretch. Greater than 1 means 2. I have that 2, right? So I can compare it with this 2, right? So when a is greater than 1, my vertical stretch is a vertical stretch, right? The vertical stretch, and graph is narrower. Graph is narrower. This is what we did in our conclusion in our last class, right? So y is equals to x minus h whole square plus k. This value of a is responsible. This will tell me that what type of stretch I have. So if the value of a is greater than 1, vertical stretch and graph is narrower, but the value of a is in between 0 and 1, right? Like in decimal, 0 and 1. If value of a is, as it is here, which is half, which is 0.5, and 0.5 is in between 0 and 1. So is still vertical stretch, but this vertical stretch will be wider. Graph is wider. Graph is wider. So this is what the question was asking, that we have to prove that if a value is greater than 1, so is the graph wider, right, or narrower? So we prove that, oh yes, it is wider, right? For y is equals 2x square, it is narrower, right? We prove it by the values, and we prove it by the graph, that this graph is narrower. And then we conclude here also the same thing. A is greater than 1. Value of A is greater than 1. Vertical stretch, graph is narrower. If value of A is in between 0 and 1, vertical stretch by that amount means half the values. Here twice the values. Vertical stretch factor is 2, right? Vertical stretch factor is half, right? So if the value is 2, the graph is narrower, right? By what amount? By 2. And here it will be wider. By what amount? By half, right? So amount is here, right? The value of A, that determines that how much, right? So we have the table of values, which is clearly indicating us that the values of y are now half as compared to the y is equals to x squared, the original graph. Instead of 1, I have half. Instead of 4, I have 2. Instead of 9, I have 4.5. It's exactly half. So we conclude that if value of A is greater than 1, vertical stretch, graph is narrower. And if value of A is in between 0 and 1, vertical stretch, graph is wider. So we did all about this question, that we prove that T.O.V. and by the graph y is equals to 2x square is narrower, and the graph of y is equals to half x square is wider as compared to y is equals to x square, the original graph, right? So our original graph is in black, and then we have the red graph, which is y is equals to 2x square, which is narrower, and then we have a wider graph for y is equals to half x square, and the values are also saying the same thing. Hope you like the video. If you like it, subscribe my channel, press the bell icon button to receive the next video. Thank you for watching.